Colleagues, what I would like to do next is to show you more apps with graphical user interface. It happens that apps from statistical or say analytical category was kind of underrepresented, and I would like to close the gap here and show 3 apps from statistical analytical category and 1 app that helps to do performance analysis in a kind of visual, interactive and systematic fashion. Also, I will introduce the perspective of developer in the conversation. So we'll take a look at the source codes of the apps, and also we will see how the development process of the apps has evolved. So we will see the source code of very first apps, and we will see the source code for the app that was recently created. And I hope to illustrate that actually today it's easier and easier to create new apps than ever before. So let's start. What I would like to do next is to show you several statistical/analytical apps that helps us to understand better our training data. I will use Pascal Walk as an example. And in Supervisely there are kind of built-in statistics for image projects. So for example, if I click statistics, I will see that for each dataset how images we have in each dataset. I can see the relationships between images and classes of objects, as well as the relationships between object instances and classes. So for example, I know that say in this val dataset I have 108 instances, objects of class board. But the main problem here is that I cannot click on the number and see the images, these instances of boards immediately. So those numbers are not directly connected to the data. So in other words, the statistic might be not interactive enough. And to overcome that, what we are doing constantly, we keep developing new statistical and analytical apps, and I'm gonna show you several examples of those. So let me go to reports and stats section here and run classes stats for images app. So to make it faster, I'll just take 11% sample and run this app. So, and by the way, this classes stats for images app is actually one of the first apps that was implemented for Supervisely ecosystem. But in spite of this, it's still quite useful. So what this app is doing, it actually shows several tables. The first table just populated with data on the fly, and there will be other table and some other charts after this app will complete its execution. Once the computations are completed, we will see several tables and charts here. So the session is finished, and app computes everything. App has computed everything, and we see several tables, several charts. And what I would like to do is just to focus on this first table and explain to you what I mean when I said interactive statistics. So if I pick a column here, unlabeled, and just sort by the values in this column, what I can do here, what I can see here is that there is only one image in my sample for which every pixel is labeled. So if I click on this image, what I will see is that every pixel is actually labeled here either with neutral class or with cat or with classes of cat. If I sort this column in opposite order, I will see the images that are kind of mostly unlabeled. So most pixels are unlabeled, and it might help me to discover images that maybe miss some labeling and so on. Maybe it's normal depending on the data set. So I can expect small labeled objects on these images. So let's take a look at several examples here. Okay. Another thing that I can do with this is to pick a class, say bird, and sort sort the corresponding column. And I can see that in this sample the image that contains maximum number of birds is this one, and it's only like 7 birds here, so I can click and verify that it's the case. Last thing that I will show here is that I can click on adjacent column here for bird and find the images based on the number of pixels occupied by specific classes. So for example, in this image I can see that there is only one bird that occupies almost half of the image. So there should be like bird, zoomed in bird, like this. Okay, and there are other tables here and charts that I could probably play with, but what I would like to do next here is to take a look at the source code of this app. So we can just click here and go to the GitHub page. And if I go to source codes, what I will see is these 3 files. So 2 of them are HTML files and the last one is Python file. So this first model HTML just contains the code for this progress bar, or rather maybe it's not called progress bar, but other elements that actually helped us to define the slider, that helped us to define the sample size. So we put here, I think, 11% sample. Then if I go back and open another HTML file, this HTML file will defines graphical user interface. And actually this is the table widget that we were playing with. And in the Python code actually populates this widget with the data. And you see that overall there are 74 lines of in this HTML file. Not a huge one, but still some HTML code present here. And the Python file, and here is the Python file. Actually, it's a bit more than 300 lines of code, and I can actually search for this name. So I see that some Python code just populates this table. And the main problem with this approach is the following. So what we want to achieve at the end is that it is easier for the Python developers to create Supervisely apps. And though the HTML file is not huge, it still might be a problem. And you will see that in the latest apps, we get rid of HTML file completely. But okay, let me switch to another app here. So I just would like to show you several statistical apps. So the next one would be classes co-occurrence matrix. Let me run this one. So what this app will do is it will show us how classes of objects are interconnected. I apply this to the entire Pascal Walk project. So let's open that. And we see the table like this. And it's like a square matrix. On the rows we have classes, and on the columns we have also classes. And say if I pick a class here, say a cat, and sort this way. So I will see that here that I have like 250 images that contain cats. Maybe I am interested in more like unusual occurrences, for example, cats and dogs together. So I can see that there are like 7 cases. And moreover, I can click here on this cell and see the list of images that satisfies these conditions. So if I open an image here, what I see is that there is cat and dog together on one image as expected. Maybe I will just show you another one. So here we also see this funny picture where cat and dog are together. Okay, so and we can proceed and take another class, say boat, and see that there is like this cow and boat on the same image. That might look strange, so we may identify in Pascal Walk these funny pictures. Okay, let's quickly take a look at the source code of this app. Again, I will click here and go to the GitHub. We will see very similar picture here. So there was no model window, so it's like empty here. And there is HTML file and with some widgets, and this Python file is responsible to to fill these widgets with the data. And again, now I will show you one of the latest step that we have developed, and you will see the difference in the source code. So let me go back here and run yet another statistical app, which is called Interactive Object Distribution. Let me run that. And let's open it. I will click Calculate Stats. It will take a bit of time to process all this dataset. So let me explain what this app is doing. So it shows us the table like this. So on the rows of this table we see the classes, and on the columns we see the number of objects in image. So for example, what it say this cell tells us that there are 155 images that contains exactly one airplane, and we have like 12 images that contains exactly 2 airplanes, and we can click on this cell and see these 12 images, and moreover we can click preview, and in each of this image we should see exactly 2 airplanes. Let's check that. And also what this app allows us to do is to see kind of the general picture. So first of all we see 2 outliers. So for the class battle we see that there is an outlier image here, and we can click and see how this image looks like. So what we see here is quite a lot of battles on the background. We can inspect more outliers here, say for the class shape. Click and see how the what image satisfies these conditions. So yeah, we see quite a bunch of ships here. And also what we can say about Pascal Walk, looking at this table, is that Pascal Walk is a relatively simple data set in a way that most of the images are accumulated here in the first columns, while there are just several images that contains a lot of objects of one class. So in general, Pascal Walk considered quite simple data set. But let's take a look at the source code here. So if we go to the GitHub page now and open source code, you will not find HTML file here. So there are just 2 Python files, and this StatsPy just implements some functions that are called from this main Py file. So here is so the benefit here is that for the person who develop an app, this person don't have to be familiar with HTML at all. So it should be easier for Python developers to create Supervisely apps with this latest approach. And what I will do in the next section, I will actually show you how we can modify this app, how we can add certain action, so that we do not only see like cool statistics and gain some insight, but rather can play the data right inside this app. But I will show that in the next section. I would like to close this session, however, with yet another app. I would like to show you how we can solve a slightly different task. Suppose we have, here is another version of Pascal Walk, where we have annotations not with rectangles, not with masks, but rather with rectangles. So let me just open one of the images here. So you see like rectangular annotations of objects here, and also I have another data set here. So this is a data set with ground truth. So this is labeled by human, and this is a prediction from some version of YOLO model. And what we might be interested in is to understand how well our model is working in kind of systematic way, not just to get one number of MIP or something and trying to figure out what is it good or bad and what mistakes the model is making, but rather understand how the model works in more visual, interactive and systematic way. And for that I will use yet another app from ecosystem. So probably I will go to ecosystem here, to neural networks, images and object detection section, and I will use this object detection metrics app to illustrate how we can compare the model against ground truth in visual fashion. So I will run this app, then I will open it, and here I can select the ground truth project and the project with the predictions. So let's select our ground truth project, which is called GT Pascal Walk. And I will pick the project with the predictions, which is called prediction Pascal Walk. Let me select these projects. Let me click match button to make sure that the images in these projects are actually matched. And as a next step, I have to make sure that the classes also match. So okay, let me say that I'm interested in all the classes, and I will exclude these three last classes here. And then, as a last step, I will say that okay, I want to analyze say half of my predictions, and I can define some confidence levels and intersection over union thresholds here, and click calculate metrics. It may take about 20 seconds to calculate the statistics, and then we will see the magic. So we'll see these confusion matrices. There is nothing special about confusion matrices, but the cool thing here is that this confusion matrix is interactive. So if my model is perfect, I will only see the diagonal elements, so there will be no off-diagonal elements here. But so the way we can interpret it is the following. So if the model predicts cat and actually the truth, if the actual value is the cat, but the model predicts the bird, and we have, so there is a value of 1 here, it means that there is one occasion when there was actually a cat and the model predicted the bird. And we can see this image, and moreover we can inspect it. So the ground truth is a cat, but the prediction is that it's a bird. Probably what we see from this confusion matrix is maybe it's more common to confuse cats and dogs. So again, there are 19 cases where these two classes were confused when there was actually a cat and the model predicted the dog class, and those are these images. So I can click on any of those and see when it happened. Let me click on some. So the last one to illustrate. Yeah, so there is a cat and a dog in this image, and model make some confusions here. Okay. Last thing in this app, there are a lot of options that we can play with, but say what I would like to show next is per class analysis. So I may say, okay, I might be interested in certain class, say person, and then I can click preview, and then I may start to answer very interesting questions. So here is a false positive column, and if I sort by the values in this column, I will see the images with where my model have found the maximum number of false positives. So if I click here, I will see that I should see that there should be a lot of false detections for person class, and that's exactly what we see here. Or say alternatively, I can click on alternative image and also see that it's the case here. So probably at this point I should stop. There are a lot of statistical apps, performance analysis apps that we have and that might be extremely useful. See you in the next section when we'll speak more about the apps from developer perspective.